Welcome back. Learning with us here at MPB. I am Miss Killen, and we are back for some more Algebra 1. We are still in Unit 6, those introductions to quadratics, but now we are on Lesson 4. So let's look and see what we've got. We've got Lesson 4, Solving Quadratics and Other Equations by Factoring. We are looking at standards SSE 3A and REI 4B. I can solve equations not in standard form, and I can solve quadratic equation when A is more than 1. So let's dive on in and see what we've got. It says things to remember when solving for solutions. Not all quadratic equations will be in standard form. We've learned that standard form is our ax squared plus bx plus c. The equations will not always equal 0. Remember, our zeros are when it crosses that x-axis. And sometimes there may be a GCF in all of the terms. So let's see what we're doing. It says solve for n. Don't forget to bring the GCF along for every step. So let's go ahead and dive into this problem. So I see my 3 terms, and the first thing I'm going to do is see if I have a greatest common factor in these terms, knowing that I always start with my numbers. So my numbers are, I've got a 3, a 30, and a 168. So what I want to do is I want to look in my calculator to see what possible greatest common factors there can be. Now this is a new step for us, looking at 3. So what I want to do is I want to put it in my calculator. So we're first going to look at 3 and 30, what the greatest common factor would be for 3 and 30. So we go to Math, Numbers 9, and we put in our 3 comma, and then 30, and we get a 3. Now let's see if that 3 will go into that 168. So I do 168 divided by 3, and I get a 56. So I know that I can pull out a 3 for all 3 of those terms. Now I've got to look at those variables. Now, like we've done, I have 3 n's being multiplied to itself. I have 2 n's being multiplied to itself, and then I have 1 n. What do all 3 of those terms have in common? And like I've told you, circle what they all have in common. So I can bring out an n, and then I'm going to write what is left. N squared plus 3 divides into 30 with 10. And then 3 goes into 168, 56. So now that I have what's left, let's go ahead and factor this. Remember, I'm equaling this to 0, solving for my zeros. So we have always said that this 3n is like bad luggage, so we're just going to drag it along. And now I am factoring. Now remember, when we factor, what are the factors of 56 that will subtract to give me a positive 10? Now we can do this in our calculator under that y feature, or if we remember what our multiplication facts are, we've got 56, and I've got 1 and 56, I've got 2 and 28, I have 4 and 14, and 7 and 8. I would still find all of those factors if I did that y equals 56 over x and then go to my table. Now, I want to see which one of those pairs of factors I can subtract to get that positive 10. Yes, 4 and 14. So I'm going to use 4 and 14. But now, here's where I've got to think. I am subtracting something to get a positive 10. So how could I manipulate the 14 and the 4 to subtract to get a positive 10? Exactly right. Positive 14 minus 4. And then I have to know what my factors of n squared are, which are n and n. So now that I have factored to this point, I want to go ahead and I want to solve for my zeros. So that means I am taking each one of these factors and equaling it to 0. So I have 3n equals 0, n minus 4 equals 0, and n plus 14 equals 0. I need to get those variables by themselves in all three instances. So I'm going to start let's go from left to right. I'm dividing 3 on both sides. Ms. Killen, you can divide by 3 when you have a 0? Absolutely. I can divide 3 into a 0. I just can't divide 0 into anything. So with that remembering, I have n equals 0. My next one, I'm adding 4 to get n by itself. N equals a positive 4. Then I am subtracting 14, and n equals 14. We've also remembered that when I show my zeros or my solutions, I am putting them in numerical order. Ms. Killen, you forgot to put your negative. I have negative 14, comma, 0, comma, 4. Have to watch out for those positive and negative signs. So I've gone from my trinomial, worked my problem, and now I have found out what my solutions or my zeros are. So we've already learned this part. This is just a review. Now, one thing that I need to mention in this course, if we look under this video, there is a link to show how we can do a GCF with our calculator with 3 of our numbers. So I want to make sure after we finish this lesson, you go and you look at that video. So don't forget. So now that we've done this one, let's look and see what else we've got. It says solve for x. Well, Ms. Killen, that should be easy. X is almost by itself, but not quite. What I need to look at is I need to see if I can get it back into this form. And what did we call this form? Exactly right. It is standard form. We always want to make sure that we are putting it in standard form. So let's go back and try. So what would I need to do to put this in standard form? Well, first thing I need to do is put these binomials together. So I'm just going to use good old FOIL. Can't go wrong with good old FOIL. My first terms, which is x squared. My outer terms, which would be negative 5x. My inner terms, which is going to be plus 4x. And then my last terms, which would be negative 20. So now, always, always, always got to make sure that we are putting those like terms together. So here they are. So then let's write this. Now, it's not quite where I need it to be. It's not quite at that standard form. I need to bring that negative 8 over. To do that, I do opposite operation to get everything together. So I have x squared minus x minus 12 equals 0. Now I've got all my numbers together. Now I can start solving for my x. So we're going to start like we've always done. I'm going to bring it up here. X squared minus x minus 12 equals 0. I need the factors of 12. That will subtract to give me a negative what? Yes, that understood 1 is right there. So I need factors of 12. That will subtract to give me a negative 1. Now, we've got multiple ways we can do this. Plug it in our calculator with that y equals feature, or just remember what my factors are. So let's see what I've got for my factors. So my factors are 1 and 12, 2 and 6, 3 and 4. Now, which pair can I manipulate to get me a negative 1 if I'm subtracting? Exactly right. I can use these two. So let's go ahead and build those binomials. I've got my 3 and 4, but how am I going to subtract and get a negative 1? Positive 3 minus 4. And then the factors of x squared are my x's. Now, I've completely factored it, but it wants me to do what? Solve for x. That means I've got to get x by itself. I'm solving for my solutions or I'm solving for the roots. So let's go ahead, you get your x's together, I'm going to get my x's together, and let's compare. Here we go. So what I'm going to do is I'm going to make each one of these binomials equal to 0. I'm going to do opposite operation to get my x's by themselves. Opposite operation to get x by itself, so x. So when I put these together and show my roots, my solutions, I am going to put them in numerical order, -3, 4. Check yours, check mine, and see if you got -3, 4. Good job. Now make sure that you always put all of my factors of whatever problem I'm working equal to 0. Because I may have 3 numbers, I may have 4 numbers. You always want to make sure you're putting every single factor of that polynomial equal to 0. Good job. Let's see what our next problem is going to be. Making sure we're putting them in standard form. So here's this problem. 6m squared plus 5m equals 1. Well, Ms. Killen, that's nowhere near the standard form that I need to have it in. So let's go ahead and remind ourselves, what's standard form again? ax squared plus bx plus c equals 0. So what I'm going to do is I'm going to label them. I have A, B, and C is way over there, so I know it's not in the right form. So I want to move my terms to make them fit correctly. So I'm going to leave this 6m squared here plus this 5m, but now I'm going to have to do opposite operation to get my constant back on the correct side. So I am subtracting 1, and that's going to equal 0. So now that I have it in correct form, 6m squared plus 5m minus 1 equals 0, now I can solve for all of my possible m values. So let's go ahead and do that. Well, the first thing I notice is that my a is what? Exactly right. It's more than 1. I don't have any greatest common factors because I have 6, 5, and 1. So that means, what am I going to have to use? Exactly right. Bottoms up. Now, Ms. Killen, not remembering a lot about that bottoms up. So go ahead and pull back up those note pages that we had step by step of how to do that bottoms up, and have that notes page out with this problem so we can go step by step by step by step so you're not forgetting anything. All right, so now that we got those notes, let's go ahead and work this problem. Here we go. So I'm going to multiply my A into my C and rewrite m squared plus 5m minus 6 equals 0. Now I am factoring this trinomial like I always have, factors of 6. That will subtract to give me a positive 5. We know we have 1 and 6, 2 and 3. I'm going to use this pair of factors because I can subtract to get a positive 5. I'm going to build my 2 binomials. I have 1 and 6. Now how am I going to subtract those 2 numbers to get a positive 5? Positive 6 minus 1 gives me a positive 5, and the factors of m squared is going to be my m. Now I started this problem out by multiplying my a into my c, and just like everything else in life, we got to put stuff back where we found it. So I'm going to do opposite operation and divide it back out. Always reducing my fraction if possible. If I can't, I bring the bottom up. So I'm going to bring my bottom up and have 6m minus 1. This will reduce to 1, so I have m plus 1. Wanting to make sure that all my factors of this polynomial I am equaling to 0 and getting m by itself. So I'm going to add 1 to both sides. I'm going to divide. So m equals 1 over 6. Here's my first one. And then I'm subtracting 1. M equals. So putting this in numerical order, I have -1 comma 1 over 6. And I used bottoms up. Check your work. Look at that notes page that had all of those bottom up step-by-step information. Make sure that we did every single step. You're always wanting to make sure that you're doing those steps, those correct steps, to get to the proper way of getting that A back out, or that putting that A into your C. Good job. Make sure that you always put these in numerical order. Always want to do that. So let's look at our next problem. It says, let's do some practice. All right, so we're going to work these together. So I've got solve for Q. So what I'm doing is I'm getting Q by itself, seeing what those are. So let's go ahead and try it. First thing I notice is what? Absolutely, it's not in standard form. So I'm going to go ahead and write my standard form up here just so I remember what I've got. And I'm going to have Q squared. To move that 13Q over, I'm going to subtract it on both sides. So then my formula or my equation would look like this. Now, Ms. Killen, why did you put it in the middle? Why didn't you just put it on the end? Because when we are working with these equations, we're having to remember to put our terms in the correct degree order. I went from 2, I went to 1, then I went to my constant. So you're wanting to make sure that you're putting the degrees in order. That was a real good question. So let's finish up this question. Here we go. So I'm having to get the factors of 36 that will add to give me a -13. Now, multiple ways to find these factors. I'm just going to write them down. So I've got 36, I've got 1 and 36, I've got 2 and 18, I've got 3 and 12, I've got 4 and 9, and I've got 6 and 6. Now I need to pick out which one of these pairs will add to give me a -13. Yes, 4 and 9. So let's go ahead and build those two binomials. Now remember, this second operation tells me, since it's positive, that both of my operations are going to be the same as the first. So I'm going to have 4 and 9, 4 and 9, and then I'm going to have my Q and my Q. Now, not quite done. Still need to get those Q's by themselves, so I'm going to make sure that each of these factors equal to 0 and get Q by itself. I'm going to add 9 to both sides here. Q equals a +9. I'm going to add 4 to both sides here, and Q equals a +4. Putting them in numerical order, 4, 9. Check your work, check my work. See if we made the same progress. See if you used 4 and 9 and how you used with the adding or subtracting. And make sure that you're doing the opposite operation to get those variables by itself. That's always key, always key. So now let's look at number 2. We're looking at x squared equals -2x minus 1. So let's try this one. Let's see what we get here. So I'm going to get everything on the left side and then equal it to 0. So I'm going to add 2x plus 1, and I'm going to add 2x plus 1 over here to my x squared. Ms. Killen, you can do the whole binomial, add the whole binomial? Absolutely. I'm doing the opposite operation, so I'm just going to do the opposite in that whole binomial. It works. So let's finish this. So now I'm having to get my factors. So then I'm looking for the factors of 1 that will add to give me a 2. So what are the factors of 1? Obviously. Can I add those two numbers to get 2? Absolutely. So I have my 1 and 1. My second operation tells me they're going to be the same as my first. And I have x and x, making both of those factors equal 0, doing opposite operations. So my x equals a -1 here. My x equals a -1 here. So all I have is -1. So that means one or two things. One, we did it wrong, but we go back and we check our work and we did it right. Or it only touches the x-axis in one place, which is the way this is. X squared equals 2x, -2x minus 1 only touches my x-axis one time. That's why I got one number, all right? So let's look at our next slide and see what we're doing. Sometimes quadratics are prime. This means they cannot factor. Well, Ms. Killen, I know what a prime number is. It only has one in itself that'll multiply to get, like 3. 1 times 3 is 3, period. 1 times 11 is 11, period. So I know what prime is, but how does that work when we're dealing with polynomials? Well, let me show you. Do I have any factors of 3 that will subtract to give me a 7? Well, my factors of 3 are 1 and 3. I subtract them, I get a -2. So there's no possible way that I can use those factors of 3 to get me a +7. So Ms. Killen, what are you trying to say? I'm saying that that polynomial is prime. I cannot factor using factoring. I can't do it. Now it's time for us to master what we've learned. What is the solution to the following equations? And we've got 4. Pause the video. Go ahead, you with your table partner or you individually, go ahead and work these 4 and then come back to me and let's see what we've got. All right, I'm going to go ahead and work. You check your work with mine, check my work with yours, and let's see what we come up with. So here we go. First thing I'm going to do is I'm going to get all of my terms together. So I'm going to be subtracting 135, and I'm going to get a different color. We're going to subtract 135 on both sides. So I'm going to have 40f squared minus 30f minus 135 equals 0. I always want to see if I have a greatest common factor, and we've learned how to do that multiple ways. So I know that my greatest common factor is a 5. So I'm going to put down what's left, and I have 8f squared minus 6f minus 27. Noticing that my a is more than 1, so I'm going to bottoms up and rewrite 5 is f squared minus 6f minus 216 equals 0. Ms. Killen, we're getting to some big numbers. That's okay. We have our calculator, so don't worry. We've got the calculator. We know how to find the factors of that 216 with that y equals feature. So it's okay. Let's go back and look. So I look at those factors of 216, and what do I find out that I can subtract to get a -6? 12 and 18, exactly right. Bringing that bad luggage down, and let's go ahead and build those two binomials. I have f and f, plus and minus, +12, -18. I started this off by multiplying that a into the c, so now I've got to take it back out by division. Always remembering I am reducing those factors. So 5f plus 4 will go into both of these 3/2 time. F, I am going to have what? 2 will go into them 9/4 times. I can't reduce to get a whole number, so I'm going to bring the bottom up. So then I have 5, 2f plus 3, 4f minus 9, and all of these equal 0. So now I need to make all of them equal 0. Well, 5 can never equal 0, so I know that is completely out the way. I'm done with the 5. But I can take 2f plus 3 and equal 0. And then I can take 4f minus 9 and equal 0. getting my f by itself with opposite operation. F equals a negative 3 over 2 here. Opposite operation on this side to get my f by itself. F equals 9 over 4. So then I'm going to write these in my numerical form. So we've got negative 3 over 2, comma 9 over 4. Check your work, check my work, make sure that we've got our factoring right, make sure that we reduce correctly, and make sure that we put this in numerical order from least to greatest, all right? So that's all of number 1. Check your work. Now let's try number 2. All right, I'm going to have to erase this because I need room to work number 2. You would think it'd be easier to erase. All right, so here we go for number 2. So now I'm going to do it in a different color just so we don't get messed up. First thing I'm going to do is multiply this inside. So I have 4x squared minus 20x equals a negative 25. Now I need to get all my terms on the same side so I can equal it to 0. So I have, and let's go up here and work it. So I'm going to have 4x squared minus 20x plus 25 because we use that opposite operation to get them on the left side. So now, always, always, always look for that GCF. Always want to make sure when we are factoring these that GCF is the first thing that we do. Do I have a GCF? No, I don't, because factors of 25 are just 5 and 1. So I don't have a GCF, so then what am I going to do? Exactly right. I'm going to have to use bottoms up. So let's go ahead and do that. So I have got x squared minus 20x plus 100. Do not be afraid of big numbers. Because we have that calculator, we have that Desmos. Do not be afraid of big numbers. All right? It's just part of it. The more comfortable we get using these big numbers in those different tools with calculator or Desmos, the easier this math will become. So let's work. So I now have to find the factors of 100 that will add to give me a negative 20. So if you look in that calculator, what do you find? I'm going to use 10 and 10. So I'm going to build my two binomials, 10 and 10. This second operation tells me that both of my binomials are going to have that first operation. And then I have my x's. I started this out by multiplying that a in, so I got to put things back. I'm going to divide it back out. Always reducing my fractions. So I've got x minus 5 over 2, x minus 5 over 2. This is where our name comes from. The bottom comes up. So I have 2x minus 5 and 2x minus 5 equaling both of these to 0. Doing opposite operation to find out what my x is. So x is going to equal a positive 5 over 2 here. Opposite operation to solve for x, and it is 5 over 2. So I have one possible answer, which is positive 5 over 2 for number 2. Check your work, check my work, see if we factored correctly, see if we multiplied and divided correctly, make sure that we use the correct factors, and I think we did. All right, so let's try number 3. So let's look. We have 3v squared minus 27v equals a negative 60. So the first thing I notice when I look at this is, Ms. Killen, it is not in the correct form. My different terms are not together. So I'm going to have to do some working to get everything together so I can factor correctly. So the first thing I'm going to do is I'm going to add 60 on both sides. So I have 3v squared minus 27v plus 60 equals 0. So at this point, this is when I ask myself, I see that my a is more than 1, so I'm going to ask, do I have a greatest common factor? And if I do, what am I going to do with it? So I have 3, 27, and 60. Now, with this video showing us how to put 3 different numbers in our calculator to find the GCF or the GCD that's in our calculator, I noticed that 3 is a factor of all of these numbers. So that's going to be my greatest common factor. Let's pull it out and see what we've got. I'm going to pull out a 3, and I'm going to be left with v squared minus 9v plus 20 equals 0. Then, as normal, I'm factoring that trinomial, bringing that 3 down like bad luggage, like we've always called it. So I am looking for factors of 20 that will add to give me a negative 9. If you do any form that we've learned to find those factors, I get my factors of 20 to be 1 and 20, 2 and 10, 4 and 5. Which of those pairs can I add to get a negative 9? There you go. So I'm going to have 4 and 5. This second operation tells me that both of my binomials are going to be a negative, and I have v and v. Now that I have factored them, I'm going to make each one of these factors equal 0. 3 cannot equal 0. I cannot have $0 and $3 at the same time, so I know that is not a factor. V minus 4 equals 0, and v minus 5 equals 0. Opposite operation to get those v's by themselves. So putting them in numerical order, I have 4, 5. Check your work, check my work, make sure that we use the correct factors, make sure that we're adding and subtracting correctly, make sure that I understand that 3 cannot equal 0. So there's no way that it could be a possible solution to this equation. All right? So now let's look at our last one. Let's see what we've got. 5w plus 18w plus 0. All right, so I have them all on the same side, so I know that they are in the correct order. Now I need to look to see, is there a greatest common factor? So I've put them in my calculator with all 3 of them, like our video has shown us, and I noticed that neither one of these 5, 18, or 9 have the same. So I'm going to have to do bottoms up. So I'm going to multiply in. So I have w squared plus 18w plus 45 equals 0. Now I'm looking for factors of 45 that will add to give me an 18. So let's see. I've got 45. I've got 1 and 45. I've got, let's see, 3 and 15. 5 and 9. Any one of those work? You're right. There they are. So let's go ahead and build our binomials with our 3 and 15. This second operation tells me that both of them are going to be addition. I've got my w's. So I've built my 2 binomials. So we need to put things back by dividing my 5 out. Always wanting to reduce my fractions if I can. I can't here. So I've got 5w plus 3. And then I have w plus 3 because 15 divided by 5 is 3. I'm going to equal both of these to 0. Using my opposite operation, I'm going to get w by itself, and I get what? Let's see. I'm subtracting 3, and I'm dividing by 5. And then I am going to subtract 3. So when I am looking at this, I'm going to put my negative 3, comma, negative 3 over 5. Check your work. Check my work. I multiplied the 5 in, got my factors of 45 to build those two binomials, divided my 5 back out, could not reduce that 5 over 3, so my 5 came up, 5w plus 3, 15 divided by 5 gives me 3. Do my opposite operations and I get -3, -3/5. Check your work, check mine, see what we've got, see if we've got questions. All right, we need to remember not all quadratics will be in standard form. Sometimes there's going to be a GCF with all of my terms, sometimes there's not. Sometimes I'm going to have to do that bottoms up. Our equations will not always equal 0, so sometimes I'm going to have to move some terms around so that I can equal that to 0 so I can find those solutions. Thank you for coming to learn with us here at MPB. I've had so much fun. I'm Ms. Killen. Have a great day.